Two-way frequency tables by Justin D'Souza. The learning objective of this lesson is to construct and interpret two-way frequency tables and use them to determine whether events are independent. And the keywords are two-way frequency table, marginal frequencies, joint frequencies, and relative frequency. We will look into all of these terms in the coming slides. Independent events in frequency tables. Now over here, you can see a table. This is also called as a contingency table. The other word is two-way frequency table. You can use any of them. Now what it shows you is there's some sort of data of two different types and the totals are over here. Now here they have specifically mentioned men and women showering in the morning or in the evening. They have taken a data for two different types, that is men and women, and two different sort of data, that is showering in the morning and in the evening. So women showering in the morning is over here and in the evening is over here in this part. Same way for men, first part and the second part. And then this over here, the last column is the total number of people. All men and women, all those who have been surveyed or all those who are in the study. So if you look at this is all those who showered in the morning. They're added up together. This is the one. The evening over here and women and men. But if you add all of these, four or any of these two, you will get total as 220. Now that's a two-way frequency table. Very simple, isn't it? Now here they have just told what is it. But there's one more thing. This totals, both the side, the bottommost row and bottommost column, last column, are the marginal frequencies. Over here, basically, they are called the total columns. Now here, what is a relative frequency? Now this two-way frequency table was just what we have seen a while ago. See, this is two-way frequency table. Now if you add the word relative, then we find a sort of probability. That is, for all these data, we are dividing by the total number. What is the total over here? 220, right? We're dividing it throughout. This over here is the two-way relative frequencies. And whatever the data we are reported in the interior, they are called joint frequencies, all these. But when you divide throughout each data by the total number, it's two-way relative frequency. So this is the difference. Now we can see this is the relative frequency table. And you also can find independent or non-independent. Now we will see that in a problem properly. But whenever you multiply the totals of say women over here, the total of women and showering in the morning, then you will exactly get this part. If you get those, then that is independent. But if you don't, it's not. We will look into a problem and you'll understand much better later on. But as of now, we will just look into how to make this table. We have a problem here. Francisca asks a random sample of 140 upperclassmen at a high school. So the total is given 140. Whether they prefer eating breakfast at home or at school. She finds that 55 juniors and 23 seniors prefer eating breakfast at home before school, while 12 juniors and 50 seniors prefer eating breakfast at school. We need to organize these responses in a two-way frequency table. So let's do a two-way frequency table. So let me just draw some columns. Now, so the first one will be the headers. Over here also there will be the same thing, the headers. And then over here, next one, you can write it as juniors and then seniors. And then the last one is for totals. The same thing over here, eating breakfast at home, school, and the total. Okay, it's a rough table. You can draw it in scale and make it more accurate. Now, the first column is always blank. Now, over here, you can write junior, senior, or you can write eating breakfast at home or school. Let's just read which is given first. They prefer eating breakfast at home or at school. Okay. And juniors, seniors. Junior J, seniors S. I'll write SE, SC. This is school, this is seniors. And this is total T, this is also total T. Let's see how many juniors eat breakfast at home. At home, it is 55 juniors and 23 seniors. How many at school? 12, and 50. Now add them up. When you add 50, 70, 78, over here it'll be 62. So add these, it'll be over here, if you added 70, 70, it's 140. So yes, it matches. Now same thing over here. 50 plus 10 is 60, 67. And then what do we go? 50, 60, 73. Now add this 3 up over here, 70, 70, yeah, it'll be 140. This is correct. So this is the two-way relative frequency table. That's the part A, you know. Now let's just check the answer. Over here they have explained how we can get the table. You can just directly get the table, that's it. Okay, now I just realized they have written senior, junior, that's fine. I've written junior, senior. The answers will be the same, doesn't matter, okay? This is the table basically. It is just that in the example answer over here, they have shifted this particular column down and this one up. That's fine. The next part, let's go to the part B. Okay, construct a relative frequency table. What do we do over here? All you need to do is divide everything by 140 and put it in the calculator, and that's it. That'll be your relative frequency table. I'll just write divided by 140. You need to take your calculator and divide. I can only say for certain this one will be 100% because it'll be 140 by 140. It's 100. It's 1. Usually we write it as percentage. Okay, this is the relative frequency table, but in exam it's better you solve it in the calculator, press ST and write the percent. To get the percent you need to just multiply this by 100. Multiply it by 100. Here all you need to do is 55 divided by 140 and just multiply by 100. That will be in terms of percent. It'll be 39.29%. If you're just looking at the answer, this is the answer. Now, this is, see, it's shifted up and down, right? So it is 39.29, but they've just rounded off to one decimal nearest 10. So it's 39.3. The juniors and at home is 39.3 over here, you can see in terms of percent. Now for the next one, just change this from, see this 50, let's make it 23 now. This is 16.4%. You can see it's 16.4. About seniors eating at home, that's the thing. Now same thing for the others, just keep on changing this to all, and you will get 8.6%. You can see over here 8.6, and same thing if you solve this over here and all the others, you can get the answers easily. Please make sure you keep it in percentage. That's your relative frequency table. That's it. Now let's go to the independence and relative frequency. Here in the question, they have already given us the frequency table. It's about music. Anod polls 240 of his friends on social media about what grade they are in and whether they prefer electronic dance music, that's denoted as EDM, or hip hop. He posts the result of the survey in table. See over here. Use the table to determine whether the respondent's musical preferences is independent of his or her grade level. Now, independence. So, first of all, this is just a frequency table. It's not relative frequency. To find relative frequency, what do? We need to divide everything by the total. So here you need to divide by 240, by 240, everything by 240. Why? Because this is the total, right? Even the total by the same 240 itself. So it'll be, this is the relative frequency table. Now you need to put in the calculator and find the percent, that is multiply by 100 and find the percent. Let's just take that directly. See over here they have, where is it? See, this is the answers. All they have done is divide everything by 240 and get the answer. Now I will tell you how to find whether it's independence or no. You need to have your calculator for this. Now if you multiply these totals and then we get particular values over here, then they are basically independent of their particular levels, grade levels over here, senior or freshman. They are independent, that's the thing. Now let's start doing it. 86.3, don't forget the percent symbol, or you can take it as 0.863. Please remember the percent symbol is very important. Multiply by the total of this one, EDM. It is 48.3%. Now what is the answer? This is, if you multiply this by 100, you get in percent. It's 41.68, that is 41.7. Look over here. When we multiply the total freshmen with the total EDM, we get freshmen with EDM, So that means this particular, let's do for other things also. It should be same for all. Then they are basically, these relative frequencies are independent of the grade levels. Let's check that. Now let's do it, say, for this high school seniors. Let us see whether EDM is independent of the grade level. Now we need to multiply the two. If you're taking this value, this row, and this column. So it'll be 13.8. That is over here. I'll just change. Let me change it everything. 13.8% multiplied with 48.3%, and I need to get 0. It'll be 1267. Yes, 6 makes it 7. Okay, 6.7%. That's correct. Now we need to try this total with over here, this total with over here. I'll do this and this first because 13 is already written. I'll just change this quickly to 51.7%. It must be, yes, 7.1, as you can see. And lastly, this 86 over here, let me just change this. 80 multiplied by 86.3%, and this gives us, oh sorry, now we have not changed this one. I can't multiply these both. I won't get any answer for sure. I need to multiply this and this. I basically changed the wrong term. Anyways, 51.7 multiplied by 86.3. I must get 44.6. Yes, we are getting that. So now this means they are all independent of their grade level. This is how we can find independence. So you need to basically see one, you find relative frequency table, right? They expect you to find another one just by the totals. From the totals, you need to find again and just compare these tables. Comparing the two tables, the expected and the actual relative. See, expected is what we get directly, and the actual, sorry, expected is what we multiply and get over here. These just now I did right in the calculator. Actual is from the table, what we divide, You can see they are same. Therefore, the musical preferences for these respondents are independent of these grade levels. It doesn't matter. There is a check problem. I would highly encourage all of you to solve this by yourselves. So how do we get the relative frequency table? It's by dividing everything by 28, isn't it? So just divide everything by 28 here. I'll just leave it as it is. I'm not going to put everything in calculator and find the percentages, but I'll directly use these values multiplied by 100 when I'm solving. Now we need our calculators for this. To find whether they are independent, the totals must be multiplied and then checked over here. Now, I didn't read the question, but you can read it, but the data is already given, so I directly jump to it, okay? It's about, if you have studied 4 hours or less, then what is the percent of guessing the problems, less than 5 or more than 5? If they have studied more than 4 hours for a test, how many hours, guessed less than 5 or more than 5? So this is how, and the totals are given. Now I will multiply this total. 12 divided by 28. I don't need to multiply the percent now. I'll just do this directly. 21 divided by 28. The answer is 9 by 28. Why I did not multiply the percent? Both I have kept in this form itself. That's fine. If I do percentage, both must be in percent and then I will get this. Okay, that's fine. But now you can see it's 9 by 28. Okay, is basically 32.1%. 9 by 28. I've just kept everything and divide by 28. So here this is the correct answer. But we need to check for every other value as well. Okay, this total with this is done. I'll do this 12 by 28 with 7 by 28 now. I'll just change this over here. I should get guessing more than 5. Yes, it's 3 by 28. Now I will leave this. I'll just change this 12 to 16. And is it now it's 1 by 7? Yes. What is 4 by 28 basically? 4 is divisible by 28. 4 one time, 4 7 times. 7 fours are 28, right? So it's 1 by 7. That means it's 4 by 28 itself. Both are 14.28. You can check that. And lastly, what do we have? 16, this total, and over here. So I will just change the 7 to 21. And what do we have? 3 by 7. Yes, again, 4 3 times is 12 and 4 7 times. So it is 3 by 7 is correct. Now I'll just show you 12 by 28. Yes, 3 by 7. And you can try 4 by 28 would be 1 by 7. So yes, we are getting the actual values, the relative, the actual and the the found out values are equal, the same. Both the tables will be same. Therefore, they are independent of studying whether 4 hours or more. They are just basically independent the values. So this is how we solve for independence and relative frequency. Now here you can see since we got the same values, this particular statement is true. Now, the last problem in this lesson, it is about conditional probability. Conditional probability is something we studied in the last lesson. We have been given some data. We need to use this data and use the concept of the last lesson. Over here, let's make the table first. We know it will always be 1, 2, 3, 4. The first one is for the headers, the second one for one data, third, and the last one is for totals. So here, Abu posts a question to an online forum about the originality of posts to the site. 55 respondents who have posted viral memes, 27 photos, and 15 videos were not original content. And about originality, basically, one is not original, one more is original content, and it's about photos and videos. So let's just write it over here. There are 27 photos that are not original, so 27, and there are 15 videos that are not original, whereas only 3 photos were original and 10 videos were original. So the totals over here, let's add them up. 13, 25, here it's 30, 42. 42 plus 13 would be 55. And over here it would be 30. 30 plus 25 is also 55. So this is the frequency table. Now we need to do relative frequency. So just divide everything by 55 over here. So that is it. So that is, here even the totals need to be divided by 55. Everything divided by the total. So this is 55. That is it. Now, generally, they ask this relative frequency table with percentage. So put it in the calculator and solve it for percent. That's the answer for this. Let's go to the part B because they have asked part A and part B. Okay, now I have not kept it in percentage, but if you solve it, it'll be in percentage. And I just realized the videos are first, photos are second. It's fine, whichever you do, the table will be correct itself. And the part B is to find the probability that a viral meme on the forum is not original content given that it's a photo. So it's what we had done in the last lesson. Probability, conditional probability. What is the condition? It's a photo. What is the probability? Probability that the viral is not original content. Not original content provided it's a photo. This is the probability what we need to solve. The formula for that is probability of not original intersecting photo divided by probability of photo only. So what is the probability of content that is not original and photo? This is and, intersection is and. It's over here. 27 by 55, isn't it? Divided by what is the probability of photo only? Like photo. Photo is the total, right? 30 by 55. Now you can avoid writing this because it anyways cancels off. It's 27 by 30. Just use a calculator and solve this up. Just put it in the calculator, 27 by 30. The answer is 90. So it is 0.9, 90%. Okay, we will just check the answer. Yeah, it's 90.1. See, you realize why it's this? Because they have taken 27 by 55 as percent. So now, over here, if I take this 27 divided by 55, I'm not going to take this entire values, isn't it? I'm just going to take 49.1. So it'll be 49.1. And the same thing over here below, also they have taken 0.54.5%. 54.5. Both are in percent. And that would make this 90.1. Can you see that? But actually 90 0.09 would be 90.1. Actually, 90% is the actual answer if you directly take it like this as fractions itself. So the probability that the viral meme on the forum is not original, given the condition is photo, is 90%. So that's the thing. Now, if you're just getting confused, I'll just quickly recap this because we have done in detail in the previous lesson. Now, this is conditional probability. Whenever there is conditional probability, first you need to know what is the condition. Condition is always given statement, okay? Given that this is a photo, that will be slash p. It's always in the denominator. And then, what is the actual probability of a viral meme on the forum which is not original? Not original, given that it is given condition probability. The formula is always the above part, numerator is intersection of both. That means and. Not original and photo. Over here in this table, we know not original and photo is 27/55. Divided by the probability it's a photo, that means the total number of photos is 30/55. When you solve this up, you'll get 90%. That would be the answer. So this is how we solve these problems, and that's the end of this lesson. I hope you have found it beneficial. Please do share my videos with your friends. Please do like my videos. And if you have not yet subscribed, please do subscribe. And if you have already subscribed, thank you so much. I really appreciate it. Until the next video, wish you all happy learning. Take care, guys. Bye bye for now.